in yesterday's lesson. If you were not here yesterday, those 3 warm-up problems were recorded. They are on Blackboard, so you can watch the video for how we work those out together as a class. So for right now, what we're going to go ahead and do is get started with some of our basic identities. Oh, and yesterday in class, also on the video, you should see that there, and I uploaded this PDF file as well. If you weren't here yesterday, there are some worked out samples from your homework from, I guess it would be Friday night, right? So there are a couple problems that we worked out together when we went over that homework assignment yesterday in class. So if you weren't here yesterday, that's for you. Okay, so now we're on example 1. And what you're asked to do in example 1 is verify. That's fancy talk for prove that each of the following is true by using our identities. So, in part A, you'll see that we are asked to prove or verify via our identities that the secant of an angle times the cotangent of that same angle is equal to the cosine of that angle. That's actually a typo, because when you multiply those two things together, you can't get cosine. This should actually read CSC of our angle T. All right, so here's what I do. My mission is to start with what's on the left and make it so that I can get what's on the right. It's not a bad idea to think about, before you jump all into the problem, just throwing identities into things, it's not a bad idea to think about what the right side is equal to. So here's me thinking about cosecant. And hopefully they're in your brain. If not, I did give the class yesterday some flashcards. But hopefully, hopefully they're in your brain. But if not, I need to know something that cosecant is equal to. So you could look at your chart or look at your flashcards. What do you think, Clay? What's something that cosecant is equal to? It's totally true. Yeah, it is 1 over the sine of that same angle. So what I have to think about right now, my ears are all clogged, I can't hear. What I have to think about right now is how could I turn secant and cotangent somehow into 1 over the sine? So I need sine to be on that left side of the equal sign. And right now, as it stands, it is not. So what I'm going to go ahead and do is I'm going to think, what's another way I could rewrite secant? It's another way to rewrite secant, an identity, if you will. Go ahead, Clay. It is 1 over cosine. And what's another way of writing cotangent? Remember, we're trying to get to sine. What do you think? It is 1 over tangent. It's an angle. It's like theta x. It means an angle measure. So, yeah. And Devin, these identities will work for any value of theta. So you could plug in 30 degrees. You could plug in 7 pi over 6. You could plug in any identity or any angle you want. Theta, t, x, y, like those things. You want me to use theta? Is that right? I like theta too. Your book last night used alpha. Sometimes you see beta. But those Greek letters, not x's and y's, but those Greek letters are always angle measures. That's alpha. That's theta. Same thing. Yeah. Sorry. Back to cotangent. So, Emily, you said it's 1 over tangent, right? Okay. So, remember, I said you can't be fearful of making a mistake. So Emily's like, oh man, I made a mistake. But I'm so glad you did. You have to put the pencil to the paper to sometimes work these things out. You can't be scared of just taking a shot, picking something that it's equal to, and seeing what you get. So Emily, I'm going to go with what you said. I'm going to say that cotangent is equal to 1 over tangent. If I do the operation in between, if I do this multiplication right now, I get 1 over cosine tangent. And that doesn't get me sine. So I have to think of something else. So I'm going to keep the 1 over the cosine. I need to think of another way of rewriting cotangent. Katie. Yes, it is. The quotient identity tells us that cotangent is also equal to the ratio of the cosine of the angle over the sine of the angle. Now watch this. Do you see it, Clay? Do you see what happens? It kind of makes the homework click a little better, yeah. If you have 1 over the cosine times cosine over sine, college algebra fans, do you remember what happens when we multiply 2 fractions and you have the same? Yeah, you can cancel. Good, Devin. So I can cancel these cosines, and I get 1 over the sine of the angle, which is the same thing as cosecant. Bang, done. So you start with what's on the left, and your mission is to try to get to what's on the right. It is difficult. The hard is what makes it great, right? League of their own. It's a good movie. All right, let's do it again. Part B. Because that was what was on the right side of the equal sign. It was a typo. Okay, but there's no more of those. Part B. So I have the sine of an angle times the cosine of an angle, or cotangent of an angle. Oh my goodness. And this is supposed to equal the cosine of an angle. You don't always have to switch out everything in the problem. You don't. But what I do see is that I'm trying to get back to cosine. So having cotangent there doesn't get me any sines or cosines. So I'm going to switch out cotangent right off the bat. Cotangent is actually equal to cosine over sine. Sine is just, well, good old sine. Here, my sines cross cancel, and poof. I get what's on the right side of the equal sign. So that's done. One more time and then we do it on our own. Part C. I have tangent times cotangent, and I'm supposed to show why that equals 1. So the first thing we have to do is pick some identities for tangent and cotangent. No.
We just canceled those.
We took what's on the left side, we rewrote it, did some algebra to get what was on the right side. It's all letters. Yeah, you're correct about that, Devin. That happens.
It's true. C was 1.
They do both cancel out. How, Clay? Yes. So he's using the quotient identities. So he's seeing that tan is the same thing as sine over cosine, and that cotan is equal to cosine over sine. If we multiply these things together, we get 1. Now that's not the only way you could have done that problem. You could have also used reciprocal identities. So for instance, tangent times 1 over tangent is going to give you tangent over tangent, which is 1. Oh, part D. You're all going to try that one. Ready, set, go. Don't say it yet. I'm going to come over and check you. You guys did good. I'll take this. All right, so what I see as I walk around, you use the quotient identity to turn tan alpha, or tan fish, Devin affectionately calls it, sine over cosine, goldfish, and then cosine alpha over 1. Cross cancel your cosines, poof! Sine alpha is what you get. You know you're done because you got to the right side, by the way. All right. Now, they're not always like this, let's be honest. Please keep in mind that in this case, I was asked to multiply two things together on the left side. And ultimately, I did that. If you take a look at the last problem on the note sheet, at least for today, we are going to do a couple more. But if you take a look at the last problem on the note sheet for today, again, we always have to do, ultimately, the operation that's on the left side. So right now, I'm like, oh my goodness, I see two parentheses multiplied together. So I'm not going to cross cancel like I did with ratios. I'm going to FOIL them. Very good. So I FOIL. So 1 times 1 for my first, that's 1. The outers is negative cosine theta. The inners is positive cosine theta. And then the last is negative cosine squared theta. And then I look, I'm like, oh, look, the oids cancel. So my outers and inners go away. And what I'm left with is 1 minus cosine squared theta. 1 minus cosine squared theta, you could just say that that is equal to sine squared theta. But you're not done. There's a reason why this is true, why I can make the leap from this side to this side. And here's why. It is because of this particular Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Yes, isn't it? That's a comment. I need a question. So here, notice that I was getting sine squared theta by itself on the left side. So if I want to solve this equation for sine squared theta, get that by itself, you could, technically speaking, just subtract cosine squared theta from both sides. So what you end up with is sine squared theta does indeed equal 1 minus cosine squared theta. It's just the Pythagorean identity. It's on your paper. Don't pick on little Devin. Well, first of all, I need somebody to read for me the problem that is on number 3. Cotangent theta. Yeah. Okay. All right. So in the back of my mind, and I've done this a couple times with you folks today, in the back of my mind, what I'm thinking about is how cosecant is the same thing as 1 over the sine of theta. That's the only thing I can get cosecant to be equal to. So what I more or less have to do right now is turn everything that's on the left side, condense it down somehow to get that to simplify to be 1 over the sine of theta. Well, that's not necessarily doable right now if I look at tangent the way it is and cotangent the way it is. So the first thing I'm going to do is I'm going to swap out tangent and cotangent so that they're written in terms of sine and cosine. So tan of theta is the same as sine over cosine. Bring down my plus. Cotangent of theta is equal to the cosine of theta over the sine of theta. And I'm going to bring down cosine theta that was out in front here. Did you? Okay. Did you distribute the cosine in next? He said gee willikers. Okay. That is what you're going to do. You're going to distribute your cosine into the parentheses here. So if you distribute cosine to sine over cosine, these cosines go away, and you're left with the sine of theta. If I distribute now cosine of theta into the second fraction, I can't cancel. That's super annoying. We end up with cosine squared theta over sine theta. Okay, now what's annoying is you always have to do this operation. When it was two parentheses multiplied together, we had to FOIL. When they were rational expressions, we had to cross cancel and multiply. This operation must be done. You might recall, before I started this section, we did a review on rational expressions, because sometimes you have to add the rational expressions together. Now if I take a look at this problem right now, I'm upset because I can't add. Why can't I add these fractions together right now? I don't have a common denominator, right? So I need to identify the common denominator between sine and 1. What is that? It's just sine theta. Yep. You put them together, you get sine theta, right? So I have to multiply the bottom by sine of theta to get these denominators to be the same. What you do to the bottom of a fraction, you must have to do to the top. So now rewriting what I have to simplify this here, I have sine times sine, which is sine squared theta, over sine theta, plus cosine squared theta over sine theta. And I can now add these things together. Remember, when we add rational expressions, you add straight across the top. So what I have right now is sine squared theta plus cosine squared theta over sine theta. Okay, I have a question for you. You ready? Here's my question. What is sine squared theta plus cosine squared theta equal to? It is 1. Very good. Quick and accurate. I love it. All right, so what I have right now is 1 over sine theta. Did you see what I was trying to get back to at the beginning? 1 over sine theta. And that is officially equal to the cosecant of theta. I'm at the right side of the equal sign, so I'm done. Number 4 is just like it. So like I said, monkey see, monkey do. If you could do number 3, you could do number 4. So why don't you go ahead and give it a try. Again, your assignment for tonight is just the first 8. We're going to talk about the back a little bit more.